In my video about visual question answering, link in the description, I knocked multiple choice questions, to which one of my former students, who apparently is still watching my videos long after it's no longer required, kudos, said that I use multiple choice questions on my exam. Does that make me a hypocrite? Well, I probably am a hypocrite, but some multiple choice questions are better than others. Recall that I'm a big proponent of the Manchester paradigm, using skilled question askers to better evaluate and train artificial intelligence. What does the Manchester paradigm have to say about multiple choice questions? I'm going to use some vocabulary from item response theory, so if you haven't seen that video, you may want to check that out first, link in the description. But regardless, let's do a whirlwind review of some of the terms that I'll be using. A question should be feasible. Answering the question shouldn't devolve into random guessing. A question should be discriminative, separate high-skill subjects from low-skill subjects, and should have appropriate difficulty. A multiple-choice question has a couple of parts: a stem that introduces the question, one right answer, and several distractors. I'm taking my examples from Don Zamaro, who focuses on evaluating humans. As a professor, these are useful tips because I sometimes use multiple choice questions for my courses. But I'm making this video because these concepts are also important for evaluating computers. Tip number 1, there shouldn't be non-semantic clues that tell you what the answer is. These are sometimes called annotation artifacts in machine learning datasets, and usually happen when you automatically generate alternatives or draw alternatives from other examples. The question on the left effectively eliminates options A and B, which start with a vowel and thus are inconsistent with the article A, making the question much easier. A less blatant example, all of the distractors should be plausible. Here, humans need to eat, so a 0-calorie diet can immediately be excluded. Tip number 2, answers shouldn't overlap conceptually. If one choice entails another, this either decreases the difficulty, you could throw out 2 answers at once, or it decreases the feasibility, the answer entails a distractor. And while the previous example about overlap was subtle, many bad multiple choice questions do this explicitly. None of the above choices diminish the discriminability of a question and lead to questions that are less useful as an evaluation tool. This also applies to multiple choice options like A and B. And while the previous example about overlap was subtle, many bad multiple choice questions do this explicitly. None of the above choices diminish the discriminability of questions and lead to questions that are less useful as an evaluation tool. And this also applies to options like A and B. Third, the distractors should be distinct, but otherwise similar as possible to the answer. On the left, you have answers that are clearly wrong. Harry Truman and Grover Cleveland weren't even alive in 1812. While on the right, the answers are much more plausible. From a machine perspective, the token 1812 wouldn't even appear on their Wikipedia pages. So it would be easy for the computer to get this right without much real knowledge. Fourth, focus on reasoning more than lookup. A BERT-based model can answer the top question here without doing any reasoning. Just look up a definition. This does nothing to test whether it can actually compute a mean. The second question actually tests the ability rather than just recall of the definition. Here's another example of this. Numbers aren't always a better answer than text. While the first question just requires you to look something up and regurgitate a value, the second version actually tests why the number is important and puts it into a relationship with other numbers. You could imagine that the first one is just a simple SQL lookup, while the second one actually requires a comparison. And because this is so important, one more example. In the first question, it is again asking for regurgitation. In the second question, it gets to why a ribosome is important for a cell and what function it plays. Of course, it's harder to write these questions than regurgitation questions. It's not that much harder. For instance, if you rewrote the question to be about lysosomes, you could keep the general structure, but you'd have to ask about the preponderance of waste macromolecules rather than an absence of proteins, the things that ribosomes make. Fifth, have questions that focus on one aspect of a skill. The top question is an implicit vocabulary test because of highfalutin words like promiscuous, pernicious, and deleterious. Now, it's perfectly cromulent to test this sort of thing, but if you want to do that, create another question for this. Combining it into a single question creates questions that are too difficult. Only someone who knows the underlying medical fact and the vocabulary will get it right. If you care about both pieces of information, have two separate questions. This will result in a better overall test and allow more subjects to show their knowledge. To wrap up, writing questions is a skill. It's hard work. Just as IRT can help you find bad questions, the art of writing questions can help artificial intelligence do a better job of training and evaluating systems. And while there isn't as much glamour in carefully crafting questions, this is something that I think can be learned from the Manchester paradigm and applied to artificial intelligence. Whether you're creating free response questions, pyramidal factoid questions, or multiple choice questions. And personally, I think writing these questions is pretty fun. You learn something, and seeing either a human or a computer struggle with the complexity and get there in the end is pretty rewarding. Hopefully you'll have a fraction of this fun as you admire the skill of creating these questions when you take your next exam. If so, tell me about it in the comments. This is just a single lecture from a course. YouTube likes to show you these videos out of order, but if you go to the course webpage linked below, you can see the lectures in the right order, and you can get resources like homeworks or suggested reading. You can also visit quanta.org if you want to learn about our systems for creating computers that can answer questions, where Quanta stands for question answering is not a trivial activity. If you want to help the channel, provide a big gradient to the algorithm by liking and subscribing.